Okay, welcome to this demonstration of lenses and mirrors. This applet represents both a lens. You can have a lens with that converges, as we have here, or you can have a lens that diverges. All right, you just change the positive and negative. Positive means converging, negative means diverging. So we'll start with a converging lens. Now, with a converging lens, the principal focus is actually on the opposite side of the lens than the object. The object is over here. I'm just moving it right here. And as you can see, you get an image, just this little image over on the right here. This image is, of course, going to be produced by this lens. Now, some of the properties of the image can be, is it bigger or smaller? Or is it magnified or diminished? Is it erect, or that is right side up, or is it inverted? And of course, is it real or is it virtual? Now remember that if an image is inverted, that automatically means it is a real image. If the image is erect, as in this condition, you can see that the object here is very close to the lens, and we have an image that is actually erect or right side up. That would be a virtual image. And we can look at the different properties as we move the object closer and closer to the lens. We can see what happens. Now, if you have an object that is quite a distance from the lens, then of course what you'll get, and as you can see, the image is quite small, and the image, because it's inverted, is also real. Now as you move closer and closer to the center of curvature, the center of curvature is actually right about here, the second red line. You'll notice that right at the center of curvature, the image that's produced is exactly the same size as the object. All right, as I move further away from the center of curvature, the image gets smaller and smaller. As I move closer and closer to the center of curvature, it approaches the exact size. Now as I move closer, even within the between the center of curvature, which is here, and the focal point, then of course the object gets larger and larger. You can see that the object is getting very, very big. However, it's still inverted, so it's real, and it's just magnified. All right? Now, as we approach the focal point, the image gets huge. And at some point, at the focal point, notice that the lines that are being drawn to produce the image, they actually end up being parallel when we're exactly at the focal point. This, of course, because they're parallel, they never intersect, and so no image is actually produced. As we keep moving towards the lens from the focal point, now you have to look on the left of the lens, and you'll see that the image is now on the same side of the lens as the object, and of course it's much larger and it is erect, which means now it is a virtual image. And as I move closer and closer to the image, or to the lens, the virtual image gets smaller and smaller. Alright, so there are three conditions. Inside the focal point, you get a virtual image that is larger. At the focal point, you don't get any image at all. Between the focal point and the center of curvature, you get an image that is real and is larger. And then as you move outside the focal point, or of course right at the right at the center of curvature, you get an image that's the same size. Outside the focal point, you get an image that is smaller than the object. So there are a number of different conditions. Most of the time, the object, the image that's produced is real, except when you are inside the focal point. Inside the focal point, what do you get? You get an image that is virtual. All right? So those are the conditions for a converging lens. Now let's take a look at what happens with a diverging lens. And by the way, for a far-sighted person, that person would need a converging lens. For a nearsighted person is given a set of of diverging lenses. Now, a diverging lens spreads the light out, while a converging lens focuses the light. So you'll notice with a diverging lens, as we have up here now, the image that's produced is much smaller. As I'm far away from the lens, notice the little image here, this little green image, is very small. Notice it's also the same orientation, or in other words, it's erect or right side up. And of course, the fact that it's right side up means it is a virtual image. One of the things you'll notice with diverging lenses is that they always produce virtual images. As we move closer to the focal point and to the center of curvature, notice that the image gets bigger, but it's still going to be virtual. As we get inside, it gets larger and larger, but it's still going to be smaller than the object. And as we approach the lens, it almost gets to be the same size. All right, so far away you get a small virtual image. As you move closer, the virtual image gets bigger, but at no point is the image ever real. So with diverging lenses, the mathematics is relatively straightforward, because you always get a virtual image with a diverging lens. Remember that with a converging lens, we had all kinds of different situations. We had real that's smaller, we had real that's the same size, we had real that's bigger, we had no image, and then of course we had a virtual image that is going to be larger than the object. So those are the conditions for converging lenses and diverging lenses. Let's switch to mirrors. First kind of mirror that we'll look at is a converging mirror. All right, a converging mirror. This may often you'll see this in a makeup mirror or something that's where you're trying to make an image that is larger than life and yet is large to look at, or is large to look at but it's right side up, and that helps you to find that little bit of lettuce in your teeth or whatever it might be. So as you move closer and closer to the mirror, notice that the focal point, which is right here, this little focal point right here, and there's the center of curvature. Here's my object way out here on the left, the blue one, and the image that's produced here when I'm quite a distance from the mirror is going to be upside down, which makes it real. It's also diminished, or in other words, quite a bit smaller. Now, as I approach the center of curvature, notice that the image is getting larger. And at the center of curvature, you should notice that the image now is exactly the same size as the object. And of course, it's inverted, which means it's real. Now, as I continue to move inside between the center of curvature and the focal point, notice what happens to my image. The image is getting much larger relative to the object. And as I approach the focal point, notice that the lines at the focal point are going to be parallel. At that point, because the lines are parallel, they never meet, they never actually produce an image. Now, as I move inside the focal point, now you'll see that the image that's produced is actually on the other side of the mirror. It's over here now, and of course it's right side up. Right side up images mean that these images are virtual. And so inside the focal point, the image is always larger, it is right side up, and is virtual. So this is where you would be wanting to look in a makeup mirror to see if you can, like I said, find that little piece of lettuce on your teeth or whatever. As you move to the focal point, at the focal point you don't get any image. In between the focal point and the center of curvature, you get a real image that is larger, and at the center of curvature you get a real image that is the same size. As you move outside the center of curvature, you get a real image that is smaller than the object. All right, so those are the conditions. As you move inside the focal point, large virtual image at the focal point, no image between the focal point and the center of curvature, a larger real image at the center, an equal image that's real, and then outside the center of curvature you get a diminished real object. All right, so those are a number of different conditions for a converging mirror. Now, for a diverging mirror, there's not much to talk about. These diverging mirrors are used in stores to prevent theft. They're the ones you'll see hanging in the corner so that the person working at the till can see, has a wide field of view. And of course you have these kinds of mirrors on your on the passenger's door or on the passenger side of your car, and it often says on that objects may be closer than they appear. And that's because that mirror is designed to help you have a larger field of view, so you can see what's in the lane beside you, and you can also see perhaps how close you are to the curb when you're parking. So notice with a diverging mirror that the image, no matter where I put the object, you can see that the image is erect. In other words, it's right side up, and that means it's virtual. And of course it's always what? No matter where I put this object, the image over on the right here, the image is diminished. And notice that the image is always inside the focal point. All right, no matter how far away I move. Perhaps if I moved to an infinite distance, then the image would show up exactly at the focal point. All right, but it would be very, very, very small. All right, so for diverging mirrors, there's really not much to tell. The images are always what? The images are always smaller. The images are always virtual. And that's all there really is to the diverging mirror.